2016 relative velocity. Question 2b. A man can swim at 5/6 meters per second in still water. He swims across a river 125 meters wide. The river flows at a constant speed of 25/18 meters per second, parallel to straight banks. How long will it take him if he swims to the opposite bank? 1, as quickly as possible, which is really straightforward, and then 2, as little downstream as possible, which is going to involve quite a lot of trigonometry. So let's look at the diagram for part 1. So what's going on in this question? If the river is flowing in this direction, obviously if he swims out in this direction, he'll get there quite quickly because he's going with the stream. He's going to have to swim in this direction to go down as little as possible, or they can describe that question as directly across. So let's have a look if he goes in this direction. What pace is he swimming at? Okay, he's going in this direction. He can swim at 5/6 every second. So after 1 second, 5/6, and so on. We have the river being 125 meters wide. This brings in this sine min max question again. So this is the angle he's going to leave at. And we have t in the question, so we can get the time. So the sine of theta is equal to O, which is 125, over h, which is 5/6 times t. So let's simplify that down. We're going to get sine theta. Well, the sine theta will swap with the t. So t is equal to 125 over 5 sine theta over 6. And again, if sine theta is equal to 1, this will produce a max. So if sine theta is equal to 1, the max time will be 125 divided by 5/6. So that's 6/125 divided by 5. So that's 6/25, which is 150 seconds. Obviously, if sine is a half, it's going to increase that time. Okay, so it's little downstream as possible. Well, so that's this side of the diagram here. In here, he's going to go in this direction. So let's just bring that triangle out. We know that's 125. He's going to swim in that direction, in this direction. And let's call this angle A in here. So the I and J, so I have my J and I have my I. So what is this? Is it minus I plus J? So we're looking at, and he can swim at 5/6. So the velocity of the man relative to the river, the woman relative to the river, I think it says a man in the question, doesn't, not to be sexist, the man, okay, is equal to 5 minus plus, so minus 5/6 cos A plus times I plus 5/6, because I is adjacent here and J is opposite, plus 5/6 sine A times J. We know the velocity of the river from up here. The velocity of the river is just in the I direction in this case. So the velocity of the river will be equal to 25/18 in the I direction plus nothing in the J direction. So we could write, we're missing the velocity of the man here, which we'll need. So the velocity of the man relative to the river is the velocity of the man minus the velocity of the river. So to get the velocity of the man on its own, again, we add the other two. We've seen this a lot now. So that's equal to the velocity of the man relative to the river plus the velocity of the river, which we have up above. So let's add these two things together, this one, and see what we get. So the velocity of the man is equal to, have we got two things in the I direction? We have 25/18, and we have minus 5/6 cos A. And in the j direction, we just have that 5 over 6 sine A times j. Okay, so we're asked for time in this question. Time. So let's have to think about time. Distance. We have the distance is 125. So we have S is 125. If we think about no acceleration here, S is ut plus a half at squared. If there's no acceleration, we can say that the distance in the I direction and the j direction is S is equal to ut. Now in the j direction we have distance. We have this distance in the j direction. So let's use that first. The distance in the j direction, S is equal to ut. Let's have a look at that. So we want time. So what's time is equal to distance over u, the initial velocity. So I have in this case, so let me move it up a bit. I have in this case my distance of 125 and my velocity in the j direction is this guy here, which is 5/6 sine alpha. So if I divide this by 5 sine alpha over 6, it's going to give me, again, it's going to be 150 over sine alpha. So that's the time involved here. Now, if I can sub this back into my I direction, I should end up with an equation that I should be able to differentiate to find these angles, cos A or sine A. So u in my I direction is this guy. So again, let's sub that in. S is equal to u times t. So I'm just going to move it across to the left here. I need a bit more space. So in this case, for I, S is equal to 25 over 18 minus 5 over 6 cos A multiplied by t, which is 150 over sine A. Now they all look, I can divide all of them by 6. If I divide everything by 6, that's the easiest way to do this. There's a few different ways, but let's multiply it out. 25 over 18 by 150 over sine A minus 5 over 6 cos A by 150 over sine A. Now we should be able to simplify. So if I divide this by 3, so we divide some numbers into these. I can see the 6 goes into the 150. How many times does 6 go into 150? 6 25s. So left with 125 there. We can divide 3 into both of them to get 50. 50. So that leaves 25 times 50 over sine A minus 5 by 25 over cos A over sine A. So let's write that in simple form. So that's going to be 25 by 50, 1250 over 6 sine A minus 125 cos A over sine A. And that would all be over sine A. Now I think that's as simple as it gets. That's as simple as it gets. Okay, so let me move up here. So now what we're going to have to do is we're going to have to differentiate this. This is my distance. So if I differentiate my distance with respect to the angle, I can leave my constant outside, 125 over 3, and this becomes a quotient rule. So you guys remember differentiation, the quotient rule, the bottom squared stays on the bottom, and it's the bottom by the top differentiated. So the bottom is sine A by the top differentiated. Well, the constant disappears, and cos A goes minus cos A goes to minus sine A. So minus 3 cos A is going to become 3 sine A. 3 sine A, yep. And then we have, so that's the bottom by the top differentiated minus the top, which is 5 minus 3 cos A, by the bottom differentiated, which becomes cos A. Sine A goes to cos A. So a quite elongated looking differentiation question. Part A here was worth 15 and part B was worth 10. So one of those questions where the marks are not evenly distributed. Now, can we simplify this down? Let's have a look here. 125 over 3 by 3 sine squared A. And then we have minus 5 by cos A, minus 5 by cos A, so minus 5 cos A. And then we have a minus 3 cos A, so that's plus 3 cos A squared. Or cos squared A over sine squared A. Where is this question going? Okay, let's have a look where it goes. So if we have an equation and we differentiate it, what we're doing is we're doing that so we can get a max and min value. So we're looking, in this case, we're looking for the min value, but either way, we let both of it equal 0. Now for this to be equal to 0, this has to be equal to 0. So 3 sine squared A minus 5 cos A plus 3 cos squared A will be equal to 0. So that would mean that. So you can see where this is going now. 3 by sine squared A plus cos squared A would have to be equal to, eventually we can see some sort of solution here, that would have to be equal to bring the cos 5 cos A across. So 3 by 1 is equal to 5 cos A. Cos A is equal to 3 over 5. Now, do we have time up here? Time is 150 over sine A. Remember that from earlier? Time is equal to 150 over sine A. So obviously if cos A is 3 over 5, let's just do a quick diagram. 3 over 5 sine A is equal to 4 over 5. So 150 divided by 4 over 5 is equal to, let's see, the 187.5 seconds. So a tricky enough question there.